Hello students, this is a series of previous year questions practice part 3. The chapter name is Ray Optics. This is an important topic for board examination perspective as well as for the NEET and JEE examination. So let's begin with this question series. The first question which we have, a telescope has an objective lens of the focal length 150 centimeter and an eyepiece of focal length 5 cm. If a 50-meter tall tower at a distance of 1 kilometer is observed through the telescope in normal setting, the angle formed by the image of the tower is theta, then theta is close to 60 degree, 15 degree, 1 degree, 30 degree. Students, let's move with the solution of this question. We know that angular magnification M is equals to FO by FE. So students, here the value of focal length for an objective lens is given here, which is 150 centimeter. And the value of eyepiece is 5 meter. From here we get the value of magnification, and we know that tan beta by tan alpha is equals to angular magnification. So angular magnification we got the value 30. Tan beta is equals to tan alpha, and tan alpha it comes that if this is a building tower which is a 50 meter, it's make an angle alpha and the distance is given 1 kilometer. So tan theta is equals to perpendicular by base. From here we can say 50 by 100. From here we can calculate the value for beta, which is 60 degree. I hope there is no confusion in this question, students, and you get the result smoothly, which is a 60 degree. Next question we have, a thin convex lens of focal length small f is put on a plane mirror as shown in the figure. When an object is kept at a distance small a from the lens mirror combination, its image is formed at a distance a by 3. In front of the combination, the value of a is, this is the diagram, f, 2f, 3f, 3 by 2f. Students, let's move with the solution part. This combination will behave like a mirror of power. Like we have a power equation for a plane mirror. This is a 2pl plus a mirror. So power equation will comes 2 times of 1 by f, because if we are just taking the value of a power, so p is equals to 1 by f, and focal length for the plane mirror is infinite, so power will come 0 for the scenario. So power is comes 0 here, and we get the result for f equivalent is a minus f by 2. According to that, we can say that the behavior will be like a mirror of focal length. Using mirror equation, 1 by v plus 1 by u is equals to 1 by f equation. So for that scenario, like 1 by v plus 1 by u is equals to f equivalent in a 1 by reciprocal we get. So we just put all these values, like v comes negative minus 9 by 3 plus 1 by minus a minus 1 by f by 2. After a little bit solution, we get the value of a, which is 2f. From the option, we can say the second answer is the right answer. Third question we have, monochromatic light is incident on a glass prism of angle A. If refractive index of the material of the prism is mu, a ray is incident at an angle theta on the face AB would get transmitted through the face AC of the prism provided. So this is a diagram which is a given, and we have an options are these. Let's move with the solution part. So as a ray emerges out, R2 is less than theta c. The theta c is here the critical angle. This is critical angle. And A is equals to R1 plus R2, and here A is the angle of prism. Where R1 is equals to A minus theta C, R1 is greater than A minus theta C here. And by Snell's law, we can say mu is equals to sine I by sine R1. I1 is equals to theta. From here, we can say sine I1 is greater than mu sine R1. And sine theta is greater than mu sine. The value of R1 I am just going to put like A minus theta C. So the result which we will get, sine theta is greater than mu times sine A minus sine inverse 1 by mu. From the option we can say that the correct option is first. Next question we have, on the hot summer night, the refractive index of the air is the smallest near the ground and increase with the height from the ground. When the light beam is directed horizontally, the Huygens principle leads us to conclude that as it travels the light beam, the option first is become narrower, goes horizontally without any deflection, third, bend downwards, fourth, bend upwards. So let's move with the solution part which we have. This is the earth and ray bend upward. And this is a rare medium to denser medium. As you can see that light rays how it's moving. So according to that, the correct option is a 4. Next question we have, a thin convex lens from crown glass, which is a mu is equals to 3 by 2, has focal length small f. When it is measured in two different liquids having refractive indices 4 by 3 and 5 by 3, it has a focal length f1 and f2 respectively. The correct relation between the focal length is f1 is equals to f2 less than f, f1 is greater than f and f2 becomes negative, f2 is greater than f and f1 becomes negative, f1 and f2 both become negative. So let's move with the solution part. We have 1 by f is equals to 1 by 2 times k. K is equals to 1 by r1 minus 1 by r2. 1 by f1 is equals to 3 by 2 times of 4 by 3 minus 1, and times k is equals to 9 by 8 minus 1. So here we get 1 by 8 times of a k. Now 1 by f2 is equals to 3 by 2 into 5 by 3 minus 1 times k, 9 by 10 minus 1, k is equals to which we get minus 1 by 10, 10 times k. So here as you can see students, 1 by f1 and 1 by f2, their both values are differ and f1 is greater than f and f2 is less than 0. So according to that, the correct option is option C. Option 2 we have. Next question we have, a green light is incident from the water to the air, water interference at the critical angle theta. Select the correct statement. The entire spectrum of visible light will become out of the water and at an angle 90 degree to the normal. The spectrum of visible light whose frequency is less than that of the green light will become out of the air medium. The spectrum of the visible light whose frequency is more than that of a green light will become out the air medium. The entire spectrum of visible light will come out the water at the various angle to the normal. Solution which we have, as we can see, the green light which we fall from the water. So mu is equals to c by cm, that means the speed of a light in a vacuum with respect to speed of a light in a medium. In that case, mu r is less than mu v. So mu is equals to 1 by c. C is that critical angle. So 1 by sin c is equals to 1 by mu. C value is less for the violet. So all colors also having frequencies less than green. In this critical angle, that the green particular color, they behave as a critical angle greater than green. So YOR, yellow, orange and red, have frequency less than green. Yellow, orange and red will not comes out of the water, where blue, indigo, violet has total internal reflection occur there. Because of that, we can say the correct option is option 2. Next question which we have, the focal length of objective lens and eye lens of Galilean telescope are respectively 30 cm and 3 cm. Telescope produces virtual erect image of an object situated far away from its at least distance of a distinct vision from the eye lens. In this condition, the magnifying power of the Galilean telescope should be plus 11.2, second minus 11.2, third minus 8.8, fourth plus 8.8. We have in solutions that m is equals to minus FO by FE, that 1 plus FE by D. We have an options like FO is a given, focal length for the objective lens is a 30 and for the eyepiece is a 3. So we just put this value and we know the nearest distance for distinct vision is 25 centimeter. We put all these value and get the result minus 11.2. According to that, the correct option for this question is the first one, because this is an erect image. Next, in a compound microscope, the focal length of the objective lens is a 1.2 centimeter and the focal length of the eyepiece is a 3 centimeter. When object is kept at 1.25 centimeter in front of the objective, final image should form at infinity. Magnifying power of the compound microscope should be 200, 100, 400, 150. So, m is equals to V naught by U naught D by Fe. So 1 by F naught is equals to 1 by V naught plus 1 by U naught. We just put all these value over here, like the focal length is given 1.2 and the for eyepiece focal length is given 3 centimeter. Object kept, that is a U is given, and image formed infinity, that means 1 by infinity is given. So for that scenario, the correct answer for this question is the first one. Next question we have, the refractive index of the material of a concave lens is a mu. It is immersed in a medium of refractive index mu1. A parallel beam of a light is incident on the lens. The path if the emergence when mu1 is greater than mu is. These are the diagrams which we have given. So the medium is actually changing. If the medium is same, so from the basic knowledge we can say the lens is a diverging lens. But here is a medium is changing. For that scenario, mu1 is a mu and ray allows to move away from the normal. Because of that, we have an option first. So let's quickly see that particular thing. Like when the light rays, this mu1 is greater, that this is a denser medium and this is a rare medium. This is a rare medium. For that, when the light rays goes from denser medium to rare medium, it will goes away from the normal. So because of that, it will be already deviated from this. If this will be going away, so it will be behaving like this. Because of that, we have an options correct first. Next question we have, the diameter of the objective lens of the microscope makes an angle beta at the focus of the microscope. Further, the medium of the object and the lens is an oil of refractive index n. Then the resolving power of a microscope increases with decreasing value of n, increases with decreasing value of beta, increases with increasing value of n sine 2 beta, increases with increasing value of 1 by n sine 2 beta. Let's move with the solution part. Resolving power of the microscope is a 2 mu sine theta by lambda. According to that, the correct option is option 3. Because if we increase the value of resolving power, the value of 2 beta, n times 2 beta will be increased. Next question we have, diameter of a plano convex lens is 6 cm and thickness at the center is 3 mm. If speed of a light in material of a lens is 210 to the power 8 meter per second, the focal length of the lens is 15 cm, 20 cm, 30 cm, 10 cm. Solution which we have, 1 by f is equals to mu minus 1, 1 by r1 minus 1 by r2. We just apply these things and get the result option 3. Next question, a person lives in a high-rise building on the bank of the river 50 meter wide. Across the river, a well-lit tower of a height 40 meter. When the person who is at height of 10 meter looks through the polarizer at an appropriate angle at light of the tower reflecting from the river surface, he notes that intensity of the light coming from the distance x from his building is at least distance x, which we are that will be covering from his building, the least and the corresponding to the light coming from the light bulb at the height y on the tower. The value of the x and y we have to calculate close to this value. So refractive index of water is given 4 by 3 students. This is an important question for the JEE main examination that came in 2013. The person who is at a height of 10 meter and the building where he is actually located, that will be height of 40 meter. These are the options. First option 17 meter, second 25 meter, 22 meter and 13 meter. In this case of with 20 meter, 10 meter, 13 meter and 27 meter. Let's move with the solution part, students. This is a diagram which is actually made. So mu is equals to 10 IP. Applying here and get the result, which is option 4. Next question we have, light is incident from a medium into air at two possible angle of incidence 20 and 40 degree. In the medium travels 3 cm in a 0.2 nanosecond, the ray will have partial reflection and partial transmission in this case B, have 100% transmission in this case A, suffers total internal reflection in both case A and B, and suffers total internal reflection in case B only. So students, let's move with the solution part. Mu is equals to C by V prime, which we know that C by speed of a light in a medium. So mu is equals to 1 by C. According to that, we can say suffer total internal reflection in a case of a B. So next question we have, the image of an illuminated square is obtained on a screen with the help of a converging lens. The distance of the square from the lens is 40 centimeter. The area of the image is 9 times that of the square. The focal length of the lens is, the options are given here, 36 centimeter, 60 centimeter, 30 centimeter, 27 centimeter. Let's move with the solution part. So here m is equals to v square by u square, which is equals to 9. V square by 40 square is equals to 9 is given. So from here v is equals to 120 came. We just put this value like u is given 30 and v is given, which we calculated actually 120. When we solved this problem, the answer came 30 centimeter in the case of focal length. Next question we have the focal length of an objective and eyepiece of the telescopes are 50 centimeter and 5 centimeter respectively. If the telescope is focused for distinct vision on a scale distance 2 meter from the objective, then its magnifying power will be minus 12, minus 4, plus 8 and minus 8. Solution which we have m is equals to m1 into m2, which is v naught by u naught, 1 plus fe by d. According to that, if we just put all these value here, get the result E. I hope we get the same result as I. 16th question we have that this question has a statement first and statement second. Of the 4 choices given after the statement, choose one that best describes 2 statements. The first statement which we have, very large size telescope are reflecting telescope instead of refracting telescope. The next we have, it is easier to provide mechanical support to large size mirror than large size lens. These 4 statements, options we have is, now the correct answer for this question is 3. That means statement 1 and statement 2 both are correct, and the second explanation of the statement second is the correct for the first one. Next question we have, a light ray falls on a square glass slab as shown in the diagram. The index of refraction of the glass, if the total internal reflection is to occur at the vertical face, is equals to, these options we have, the diagram is given here. Now move with the solution part, like 1 by sin C is equals to sin 45 degree by sin 90 minus C, which comes like tan C is equals to root 2. So from here we can calculate the value of mu, which is 1 by sin C, and after solution we get the value of root 3 by 2. Next question we have, a printed page is pressed by a glass of water. The refractive index of the glass and water is 1.5 and 1.33 respectively. If the thickness of the bottom of the glass is 1 centimeter and the depth of the water is 5 centimeter, how much pages will appear to shifted if viewed from the top? Options we have 1.003 centimeter, 3.581 centimeter, 1.3533 centimeter, and 1.90 centimeter. Solution, that shift is equals to mu minus 1 times of a t. From that we can say we have a third option is the right answer. Next question we have, a breaker contains water up to a height h1 and kerosene of a height h2 above water, so that the total height of water plus kerosene is h1 plus h2. Refractive index of water is a mu1 and that of kerosene is a mu2. The apparent shift in the position of the bottom of the beaker when viewed from the above is. So we have an option as these. Apparent shift we know that delta h is equals to 1 minus 1 by mu times of h. From here we can calculate the value of h, which we can see the third option is the right answer. Next question we have, when a monochromatic red light is used instead of a blue light in a convex lens, its focal length will does not depends on the color of a light, increase, decrease, remain same. So 1 by f is equals to mu minus 1, 1 by r1 minus 1 by r2. By Cauchy's formula, we know mu is equals to a plus beta v by lambda square plus v by lambda to the power 2. As blue wavelength is less than red wavelength, So mu blue is less than mu red. Hence, F red is greater than F blue. According to this, we have a correct option second. 21st question. Let the XZ plane be the boundary between two transparent medium. Medium 1 in Z is equals to and greater than 0 has a refractive index of root 2. And medium 2 with Z is less than 0 has a refractive index of root 3. A ray of light in the medium 1 given by the vector A is equals to 6 root 3 I cap plus 8 root 3 j cap minus 10 k is incident on the plane of separation. The angle of refraction in medium 2 is 75 degree, 30 degree, 45 degree, 60 degree. So, solution which we have, note the refractive index for Z is greater than 0 and Z is less than 0. Is a different x minus y or a different xy plane should be boundary between two media, angle of incidence. So, cos I is equals to, we get this value of I which is 60 degree from Snell's law. Sin I by sin R is equals to root 3 by 2. So, value of R is becomes 45. According to this, the correct option for this question is 1. Next question we have, a car is shifted with a convex side rear view mirror of focal length 20 cm. A second car 2.8 meter behind the first car is overtaking the first car at a relative speed of 15 meter per second. The speed of the image of the second car as seen in the mirror of the first one is 1 by 15 meter per second, 10 meter per second, 15 meter per second, 1 by 10. Solution we have 1 by, for the mirrors formula, 1 by u plus 1 by v is equals to 1 by f. After differentiating, we get minus 1 by u square du by dt minus 1 by v square dv by dt. From here, dv by dt gets v square by u square du by dt. But v by u is equals to f by u minus f. Here, dv by dt comes minus f by u minus f the whole square du by dt. We just put all these values and get the result 1 by 15 centimeter. As the beam enters the medium, it will diverge, converge, diverge near the axis and converge near the periphery. Travels as a cylindrical beam. Solution which we have, as the intensity of the maximum, as the intensity is the maximum at the axis, mu will be maximum and speed will be minimum on the axis of a beam. So beam will converges. Next question we have, the speed of a light in the medium is minimum on the axis of the beam, the same everywhere in the beam, directly proportional to the intensity I, maximum on the axis of the beam. Solution we have a conceptual questions, these are, so direct answer will be minimum on the axis of the beam. 25th question we have, the transparent solid cylindrical rod has refractive index of 2 by root 3. It is surrounded by air. A light ray is incident at the midpoint of the one end of the rod as shown in the figure. The incident angle for which light ray grazes along the wall of the rod is sin inverse root 3 by 2, sin inverse 2 by root 3, sin inverse 1 by root 3 and the fourth sin inverse 1 by 2. Let's move with the solution part. Sin c is equals to root 3 by 2, sin r is equals to sin 90 minus c. So cos c will be get 1 by 2. So sin theta is equals to mu 2 by mu 1, which is option 3. I hope students you understand these questions. Next, a student measures the focal length of a convex lens by putting an object pin at a distance u from the lens and measuring the distance v of the pin image. The graph between u and v plotted by the student should look like. So a student needs a focal length as in the given, and the lens will be convex lens. Distance v is the given. These are the options. According to the solution, as we know, like 1 by v minus 1 by u is equals to 1 by f. These value comes like in the ratio of 1 by f. So as we can see, graph will be look like this. According to this, we have a third option is the right answer. Two lenses of power minus 15D plus 5D are in contact with each other. Focal length of the combination is plus 10 centimeter, minus 20 centimeter, minus 10 centimeter, plus 20 centimeter. Moving with the next part. The refractive index of a glass is a 1.520 for red light and 1.525 for the blue light. Let D1 and D2 be the angle of a minimum deviation for red and blue light respectively in the prism of this lens, this glass. So we have these options. The correct answer for this question is third one, because D is equals to mu minus 1 times of A, mu B is greater than mu R, and D2 is greater than D1. Next question we have, a fish looking up through the water seems outside world contained in a circular horizon. If the refractive index of water is a 4 by 3 and fish is a 12 centimeter below the surface, the radius of this circle in centimeter is 36 root 7, 36 by root 7, 36 root 5, 4 root 5. Solution we have R is equals to H10C. We just put this value and get this result 636 by root 7. Next question. 2 point white dots are 1 millimeter apart on the black paper. They are viewed by eye of pupil diameter 3 millimeter approximately. What is the maximum distance at which these dots can be resolved by the eye? Take the wavelength of light is a 500 nanometer. We have an options are these 5 meter, 1 meter, 6 meter, 3 meter. Solution we have y by d is greater than or equals to 1.22 lambda by d and d is less than or equals to yd by 1.22 lambda. Put this value and get the result 5 meter. Next question we have a thin glass refractive index 1.5. Lens has optical power of minus 5T in air. Its optical power in the liquid medium with refractive index 1.6 will be 1 diopter, minus 1 diopter, 25 diopter, minus 25 diopter. Solution which we have 1 by F air is equals to mu minus 1, 1 by R1 minus 1 by R2. 1 by Fm is equals to mu G minus mu M by mu M. 1 by R1 minus 1 by R2. We put this value Fm by Fa, get this result minus 1 by 8. Or a minus 8 Pm will becomes is equals to mu by Fm. According to this, the correct option is the first. Students, after the solution, result will come 1 diopter. According to this, I hope the answer will be first. Next question we have, a light ray is inclined perpendicular to the one face of a 90-degree prism and is totally internally reflected at the glass air interface. If the angle of reflection is a 45 degree, We conclude that the refractive index n, where n is a less than 1 by root 2, n is a less than root 2, n is a greater than 1 by root 2, n is a greater than root 2. Solution we have n is equals to 1 by c. According to that, the correct option is n is a less than root 2. Next question we have a plano-convex lens of refractive index 1.5 and radius of a curvature 30 cm is silver at the curved surface. Now this lens has been used from the image of an object. That what distance from this lens an object be placed in order to have a real image of the size of the object 20 centimeter, 30 centimeter, 60 centimeter or 80 centimeter. Let's move with the solution part. 1 by f is equals to 2 by f plus 1 by f. Here fm is equals to r by 2. So 1 by f is equals to 2 by f plus 2 by r. We know the formula of a lens maker. 1 by f is equals to mu minus 1 by r1 minus 1 by r2. M is equals to minus v by u, so v is equals to minus u. From here, if we apply the lens formula here, so 1 by f is equals to 1 by v minus 1 by u comes in the nature. And after putting all these values, we get this result 60 centimeter. Next question we have the angle of incidence at which reflected light is totally polarized. For a reflection from air to glass, refractive index mu is sin inverse mu, sin inverse 1 by mu, tan inverse 1 by mu and fourth tan inverse mu. Solution we have tan I is equals to mu. So according to this, mu, the value of I is equals to tan inverse mu. Next question we have to get three images of a single object, one should have two plane mirrors at an angle of 30 degree, 60 degree, 90 degree, 120 degree. Solution which we have n is equals to 360 by theta minus 1. We put this value and get the result 90 degree. Next question which we have considered telecommunication through optical fibers. Which of the following statement is not true? Optical fiber may have a homogeneous core with a suitable cladding. Optical fiber can be cladded. Refractive index. Optical fiber are subject to electromagnetic interference from outside. Optical fibers have extremely low transmission loss. The third one is wrong because our optical fiber are subjected for electromagnetic interference from inside, not outside. 37. The image formed by an objective of a compound microscope is virtual and enlarged, virtual and diminished, real and diminished, real and enlarged. The correct answer for this question is real and enlarged. If two mirrors are kept at 60 degree each other, then the number of images formed by them is 5, 6, 7, 8. Solution we have n is equals to 360 by theta minus 1. From this we can say we have a correct option is option A. 39 question we have electromagnetic waves are transverse in nature is evident by polarization, interference, reflection, diffraction. The correct answer is polarization. Next, which of the following is used in optical fibers? Total internal reflection, scattering, diffraction, refraction. Hence, the correct answer for this question is total internal reflection. Next question, an observer looks at a distance tree of height 10 meter with a telescope of magnifying power of 20. The observer, the tree appears 10 times taller, 10 times nearer, 20 times taller, 20 times nearer. The question is completely conceptual, so the correct answer is 20 times nearer. In an experiment for determination of refractive index of a glass of a prism by I minus delta plot, it was found that a ray incident at angle of 35 degree suffers a deviation of 40 degree and that it emerges at angle 79 degree. In that case, which of the following as close to the maximum possible value of the refractive index? 1.5, 1.6, 1.7, 1.8. The correct answer for this question is 1.5. So, let's move with the solution part. Like we know that I1 plus I2 is equals to A plus B. We just put this value and get the value of A, and from here we can say that A is equals to 1 by sine C. So A is less than or equals to 2C. So sine C is equals to 37 degree, which is a between lie 1 by U. So sine 37 is equals to or less than 1 by U. From hence we can say that first option is correct. To determine refractive index of a glass slab using a traveling microscope, minimum number of reading requires are 2, 4, 3, 5. So the value of U is real depth by apparent depth, which is R3 minus R1 by R2 minus R1. Reading without slab, reading with slab, reading with the sawdust on the slab. Because of that, the correct answer is 3. A heavy spherical glass body of a radius 10 cm and a refractive index 1.5 is silvered on its curved surface. A small air bubble is 6 cm below the flat surface inside it along the axis. The position of the image of the silver bubble made by the mirror is seen 14 cm below the flat surface, 20 cm below the flat surface, 16 cm below the flat surface, 30 cm below the flat surface. Solution we have 1 by V plus 1 by U is equals to 1 by F. 1 by V plus 1 by 4 is equals to 1 by F. So V is equals to 20 centimeter. And U we can get by the value of V by U. So from here U is equals to 20 centimeter. From that we can say the correct option is 2. Question number 45 is, to find the focal length of a convex mirror, a student records the following data. The focal length of the convex lens is f1 and that of a mirror f2. Then taking index correction to be negligibly small, f1 and f2 close R. So these are the options. The first option is the right answer. Let's move with the solution part. F1 must be less than 10 cm because the image formed by the convex lens is a real. F2 must be less than 25 cm because of that we are saying that answer is 1. A convex lens of focal length 30 cm, a concave lens of focal length 120 cm and a plane mirror are arranged as shown. For the object kept at the distance of 60 cm from the convex lens. This is the object which is kept 30 cm from the concave, okay, and 120 cm from the plane. So this length will be 90 cm. For the object kept the distance 60 cm from the convex lens. This will be 60 cm. Final image from the combination of a real image. So this will be 60. This point to this point, the value will be 60. This will be 20. And this complete will be given 70. So here the options are, for refraction through a convex lens, object distance is 2f is equals to 60 cm. Image is a real distance, so f is equals to get 30. Refraction through a convex lens, U is given plus 40, F minus 120. We just applied lens formula. We just found the value of V, which is 60 centimeter. Image distance for a plane mirror 10 centimeter in front of the mirror. Distance from the convex lens is equals to 60 centimeter. So the correct option is 60 centimeter from the convex lens. Students, this is all much for the today's class. I hope you understand. There are questions. If you have any doubt, so you can ask in the chat session. And till then, take care everyone. Thank you for watching this video.